Okay, we're recording. Here we are on the last lesson of Chapter 5. This is kind of a short little unit. Basically, we're just applying our graphing skills from previous units to trigonometry. And let's see if we can graph this quickly and effectively. All right. So if you did your homework, this should be easy. Step 1, what do I know? I know D is -1. So there's my central axis. Step 2, A is 2. So we go up 2 units to the maximum, and we go down 2 units to the minimum. Okay. Then we have to figure out what the period is. The B of this, I don't need to factor this one, is pi by 3. So the period is 2 pi divided by pi by 3, which is 2 pi times 3 over pi, which means the pi's cancel. And the period is 6, and that's always such a nice thing when I have to graph and B has a pi in it, because then I know I can just count by ones instead of having to count in fractions of pi. It makes life easier. And the grid's already there, so I don't really need to start making the scale. But I know that I will do an entire crest and trough, an entire cycle of the wave in 6 units. And the only other thing to figure out now is C, and C is, of course, -1. So a cosine graph starts at its maximum. So I have a maximum at -1, and then the next maximum will happen 6 units away. 1, 2, 3, 4, 5, right there. Okay. All right, now just use kind of common sense here. From -1 to 5 is 6 units. So the minimum will be halfway between the 2 maximums. Half of 6 units is 3 units. So 1, 2, 3. Again, there's one of the other perks of using nice whole numbers on my X coordinate grid, is it makes it really easy to find other things. All right, if I go from -1 to 2, then I know that my midway between these two things will be at like a half, right? So basically this is 3 units, so 1.5 units is the middle. So I will have a nodal point right in the middle there, and then 1.5 right in the middle there. I think I'm ready to draw this graph. Not my greatest drawing, but it'll do. Okay, so there. A is done. Full marks for me. Yay. I'm going to jump to part C, actually. Part C says, solve this equation graphically. So the equation is 1 equals 2 times the cosine of pi by 3 times x plus 1 minus 1. Oh, well, wait a minute. I just graphed the right-hand side. So graph 2 equations. And I graphed the right-hand side. I graphed y equals 2 cosine of pi by 3 times x plus 1 minus 1. Now I'm going to graph the left-hand side too. The left-hand side will just be y equals 1. Where is y equals 1? Let's get, everybody got that down? I'll give you a sec to catch up to me. And then start, those of you who've got all the things written down, look up at your graph. How do you graph y equals 1? What kind of a line is that? I'll give you a hint. It's either vertical or horizontal. Horizontal. It's horizontal. That always confuses people who don't remember their grade 9 or 10 very well, because they go, wait a minute, x is the horizontal axis. Why does y equals make a horizontal line? Because think about it, y is always 1. X isn't part of the equation even, so x doesn't matter. So y equals 1 is this line here. I'll do it in a different color. Oh, actually, it happens to be my maximum. Is there a restriction on here? Oh, you're right. Thank you very much. I lied a couple minutes ago when I said full marks for me. I just lost at least a half a mark. I ignored my restrictions. Let's go back and fix that, shall we? Ooh, don't do that. Sorry, let me change my eraser to just erasing the parts of the lines. There we go. Okay, so that should end right there. Let's put a solid dot on that. And it should end right here. Let's put a solid dot on that because it does say I'm only supposed to graph from -1 to 5. So there we go. Solid, there we go. And notice that that happens to be the two places where I hit the line y equals 1. So there we go. My solutions are -1 and 5. And we've done this before. We've done this before where we had complicated pieces of algebra and we broke it into two equations, a left side and a right side, assigned them both y's, and then found where those things meet. And just like last time, you might be tempted to say, oh, the solution is -1, 1 and 5, 1. But you know what? I don't care about those y coordinates. Notice the equation that I'm solving doesn't have any y coordinates in it. I invented that just to help me get the solution. The solutions are x is -1 and 5. And if it wasn't for that restriction, where would the next solution be? Where would the next one be after 5? 11, because the period's 6. And then 17, etc., etc. And going to the left, it'd be -6, -12. So how about -7? Thank you. -7, -13, -20, etc. You're counting much better than me. Thank you very much. So there we go. That is something we've done before. So, and you might be looking at that going, ugh, there must be a better way. Do I really have to break out a graph just because I want to solve an equation? You'd be surprised at how helpful this technique gets in high levels of algebra. When you get something where you look at it and go, I don't even know where to begin with the algebra techniques that'll solve this equation, you can always say, well, I have a computer that's really good at graphing things. Graph the left side of the equation, graph the right side of the equation. Wherever those curves and lines meet, those x coordinates are your answers. It's actually a really powerful tool that can save you from doing hours of algebra that you might not know how to do anyway. So having said that, this is not the kind of algebra we can't do. We did this last chapter. Now you're probably looking at it going, we didn't solve anything that looked like that last chapter. You're right. It didn't quite look like this. So I'm going to make it look like what we made algebra of last chapter. I am going to do what's called a substitution. You've seen this before. You know where you've seen this before? Here's a grade 11 flashback for you. Do you remember being asked to factor things like that? And some people want to go, oh, I'm going to expand that, and I'm going to expand that, and then I'll try factoring. That's a silly way to do it. Why don't you just let x equal a plus b, and let, that's an L and an E, y equal a minus b, and then you get x squared minus y squared, which you factor into x plus y, x minus y. And then when I'm teaching this to the grade 11s, they always go, do I have to do this substitution thing? I say yes. They go, well, why? I figured out the answer doing it took me 10 minutes longer than you weigh. Well, here is one of the places where we're going to use exactly that kind of thinking. We're going to make a substitution here. We are going to let pi by 3 times x plus 1 equal theta. And that changes the equation to look like this. Now it looks very much like the kinds of questions we did last chapter. It only has one extra step at the end. Okay, so step 1, isolate cos theta. So I'm going to add 1 to both sides. Divide both sides by 2. And then ask myself, say self, where is the cos of theta equal to 1? Okay, well, cos of theta equals 1 when theta equals 0 and 2 pi. Now, hang on a sec. Problem, theta wasn't really what I was trying to solve. I was trying to solve x. So I can say that since theta is 0 or 2 pi, pi by 3 times x plus 1 is theta, and that equals 0, or pi by 3 times x plus 1 is equal to 2 pi. And I'll divide both sides of the equation by pi by 3, which is pretty easy. That's just going to leave me with 0. And so there's one answer. And this one, I'm going to divide both sides of the equation by pi by 3. And of course, dividing by a fraction is the same as multiplying by its reciprocal. And there's my other answer. Same answer as we got from the graph. -1 and 5. Neat, huh? All right, let's try another one. Oh, sorry, I forgot there was a D part to this question. Use the graph to explain why the following has no solution. Okay, let's look at the graph. I have graphed this thing, right, on the right. When would this thing equal 3? See the problem? 3's up here. So what would I explain here? I would say something like, the graph of the function to the right of the equal sign, I'll just say the equality, has a maximum lower than 3. Therefore, no solution. Right? It's basically like you ask the question, when will this thing equal 3? And the answer is never. It won't get that high. My graph proves it. Any questions about that? It's pretty reasonable, eh? All right. Here's one where we start by giving you the equation. Kind of like the second part of 5.2. So the equation y equals 3 sine theta plus 2 is graphed below. Graphically solve the equation sine theta equals -2/3. Okay, so let's see. If I take this equation, y equals 3 sine theta plus 2, and I say, okay, if I let y equal 0, and what do you know about where y equals 0? What is y equals 0? Y equals 0 is the x-intercepts. Then I get 0 equals 3 times the sine of theta plus 2. And notice, -2 and divide by 3. That is what we're looking for. Therefore, the solution here is the x-intercepts of the above graph. Okay, so where are the x-intercepts? Well, it looks to me like one of them is halfway between pi and 3 pi by 2. So let's see, where is halfway between pi and 3 pi by 2? At least, I don't know, is that halfway? I think it is, but maybe I'm wrong. Well, you know what? I'm not 100% sure I can just read it off the graph. So why don't I actually solve it? I'll say, okay, so if I'm looking for the y-intercept, they don't give me a whole lot of room below here, so I'm going to use the room over here. If I'm looking for the x-intercepts, where y equals 0, I'm going to go sine theta. Oh, actually, I already have that written down. So 0 equals sine sorry, let me just read that better. If sine theta equals negative 2/3, I'm going to go, okay, so theta r is going to be the inverse sine of 2/3. Some of you on the last test kept forgetting that you drop the negative when you're finding a, what's the word I'm looking for here, a reference angle, because I don't want my calculator to spit out a negative angle answer. I don't really want to go this way. I want to go that way. So I will kind of keep in mind where sine is positive and negative. In fact, I can see it on here. Where is the sine going to be positive? Everywhere above the x-axis. Where is it negative? Below. So I'm looking for the inverse sine of 2/3, and I don't think that's something on my unit circle, so you know what? It's not going to be exactly halfway there. It's not something I'm going to know. So let's see. The inverse sine, I don't know if I'm in radians, and I can't see my calculator properly. Hold on. I'm going to use a different calculator. Degrees. There we go. Radians. So I'm in radians, inverse, so 2/3 inverse sine. So I get that theta r is 0.729 and change, right? 0.729. Oh, I guess it's a 7 after. I'll go with 4 decimal places. 7. Then after that, it's a 2, so it'll round to there. So 0.79. Now, where is sine equal to 2/3? Well, it's going to be somewhere around here. So now hang on. That's my reference angle, right? But I know that it has to be, by cast rule, I know that it has to be actually negative. So I want to be down here and down there. So this one would be pi plus that. So I'll just take my answer, and I'll add it to pi, and I get 3.8713, which is probably this spot right here. Get it? Because remember, pi is about 3.1, so it makes sense. That's about 3.8. And then my next answer, and I'm sorry they don't give me a whole lot of room, is the one I'd get doing this calculation, which is 2 pi minus that reference angle. So 2 times pi minus my reference angle, and that's 5.5535, which would be this point about here, which makes sense because remember, 2 pi is around 6.3, right? Or 6.28. So there we go. There's our 2 answers. So there's the kind of algebra we can do when we look at graphing equations. All right. Moving along. Let's do a word problem. Yep, we're going to do word problems. The average daily maximum temperature in Winnipeg follows a sinusoidal pattern. The lowest value of negative 14 degrees Celsius is found on January the 15th, and the highest daily temperature is 26 degrees on July the 15th. We're going to say that, counting by days, January the 1st is when x is equal to 0. Which means that January 15th, which is the 15th day of the year, since the 1st is day 0, this will be day 14. The 196th day will be day 195. And of course, there's 365 days in a year. Write a sinusoidal equation to represent this scenario using the cosine function. Okay. All right, how do I make an equation? Well, I make an equation by knowing A, B, am I going to use theta or x? I'll use x. I've already started calling him x up here. C and D. So all I got to do is use the information in front of me to find A, B, C, and D. All right, A is the easy one. Well, A and D are both the easy ones. Remember, I gave you a little formula. A is the difference between the highest point and the lowest point cut in half. So let's see, what was the maximum again? 26 degrees. What was the lowest again? 14, but I'm negative 14, but I'm minusing negative 14. Careful there. And 26 minus negative 14 is 40. 40 divided by 2 is 20. D is the average of the maximum and the minimum, so add them and divide by 2. So that's 26 minus 14 divided by 2, which is 12 divided by 2, which is 6. All right. Now, we're starting our graph in January, which is where the minimum is. Now, it told me it wanted a cosine, and I always want to try to find my c-value as close as I can to the y-axis. I don't want to go all the way across the graph to find the closest maximum when there's a minimum closer to the y-axis. But if you start a cosine graph at a minimum, what has to change about one of these numbers I just found?
Negative A or B.
The A has to be a negative. Now, I haven't started finding B yet, and I actually don't usually assign negatives to B. Kind of makes the equation a little uglier as far as I'm concerned. So that means I'm going to make this A negative because we're going to start on a minimum. There we go. So there we go. We figured out A and D. Now, what about the period? Well, the period would be, of course, the distance from a maximum to a maximum or a minimum to a minimum. What do I know? I know how many days there is between a maximum and a minimum, so I know half the period. So 1/2 of the period is the number of days that it is from the 195th day to the 14th day. So I'll just take the 195th day minus the 14th day. Now, some people might go, shouldn't you add 1 to this? And if there's people wondering, why would you add 1 to this? Well, how many days is it between day 14 and day 195? Right? If you were collecting comic books and you had issue number 14 and issue number 195 and you had all the issues between them, is this subtract how many comics you have? No, there's actually, you count the end comics. So there's actually 1 more than this subtract. I'm not going to bother doing that because I don't think I need to. So last year when I was doing this example, I said, shouldn't you actually add 1 to this to count the days that you're subtracting? And I think this will work out without it. We'll graph it on Desmos when we're done in C, but I'm pretty sure this is going to work. So 1/2 of the period that's 181. So that means my period is 362 days. Now you might be thinking, well, wait a minute, shouldn't the period be 365 days, a year? I don't think so. I think this is the way that it's going to work. We'll see. Anyway, if period's 362, B is 2 pi divided by period, which is 2 pi divided by 362. I can simplify that fraction. It's pi over 181. So there we go. I've got an equation now. Temperature as a function of what day it is, or I guess I can't use day, I have to use x, because I chose x. Temperature as a function of x, where x is what day it is negative 20. The B value I found is pi over 181, x minus 14 plus 6. And okay, I'm going to graph that on Desmos, just to see what it looks like. Okay, so, oh, I don't have Desmos open. I thought I had a Desmos open. I do not. I had one open this morning. I must have accidentally closed it. Sorry about that. All right, so this is going to be, okay, so what is it again? It's y equals negative 20. Y equals negative 20 cosine, open a bracket, Pi divided by 181, open another bracket, x minus 14, close bracket, plus 6. Okay, it's like, oh, why can't I see my graph? Because my scale is not allowing me to see my graph. I'll just change my scale until I can see it. There we go, something like that. Okay, now, it's not letting me change it in one direction only. Anyway, that's basically a year right there, right? 300 from first day to 365th day. And if I did this right, what should I know on this graph? I should know that on, let's see, on the x is 14, I should have negative 14, right? So negative 14, negative 14, or 14, negative 14 should be, there it is. And if I, my other point that I knew was on day number 195, the temperature is 26. So 195, 26 should be a point too. 195, there it is. So there we go. I've got this right. People who said, but shouldn't this be 2 pi over 365? You know what? I'm going to graph this and show you that actually that wouldn't quite work. You have to kind of work from the data you're given. Hang on. Oh, hang on. Ah, come on, you. Control-C. Control-V. And if I change this to 2 pi over 365, it looks like it's almost exactly the same graph. Look at that. But if I zoom in, they're actually not exactly the same. So if I'd have cheated and gone, oh, I don't need to figure out the period. I know that the cycle repeats in 1 year, 365 days. It's actually off by that a little. And could anybody hazard a guess as to why in real life it would be off a little from that? There isn't 365 days in a year. There's actually 364 and approximately a quarter. I say approximately because it's not exactly a quarter, which is why we skip leap year day once every odd century. So 1900 did not have a leap year day, and if you all will live to see 2100, I'll be dead. Let me know how it goes. But there will not be a leap year day that year either, because it's not even quite a quarter. The Earth doesn't go in circles, right? It's elliptical, right? So anyway, people who were going, why didn't you just make 365 the period? You know that it repeats every year. Well, take a look. The data told us it was actually slightly different. I don't know. I like this problem. This is a fun problem. Okay, and it's not over yet. Ooh, there's more. Okay, let's go back to the problem. There was a B part. Now that we have an equation, we can use it to make predictions. What's the average temperature on the 300th day? So the 300th day would be, because we counted day 1, January 1st at x is 0, that would be x is 299. And of course, I could just read it off the graph. But let's do the algebra. I would like t of 299, which means I'm replacing this x with 299. And you finally get to use your fancy scientific calculators to do some really, oops, I missed the cosine. Hang on. Where did the cosine go? Why didn't you stop me? Can you go back here and put a cosine in the equation? Did anybody write cosine even though I ignored it? Sorry, that's a mistake. There we go. And then I didn't do it here either. Let me erase that. Negative 20 cosine. There we go. Okay, so negative 20 times the cosine of, okay, I might as well do this subtract here. Pi divided by 181 times, and 299 minus 14 is 285. And that's about all I'd simplify. I would now punch buttons on my scientific calculator. Ooh, what mode should I be in? I'm in radians because of the pi's. We're not in degrees here. So I would go 20 with a negative times. And now on this calculator, I'm going to have to open a bracket and do this first. Pi divided by 181 times 285, close the bracket and hit cosine, and then hit plus 6. And okay, what are you expecting for October's average temperature? Not really cold, but not all that nice either. It's October. Did you get this? Try punching buttons and see if that's what you get. Oh, I know how else we could double check our answer too. We could go and see if that's what we read when x is 299 off our graph. So, okay, let's get off of that graph. So when x is 299, 299, 20, oh, you know what, I'm going to have to zoom in so it'll be easier to do. Oops, moving. 297, 98. It's off a bit. Come on, you. There it is, 1.356. Is that what we got? I can't remember already. Yep. Anybody punch buttons and not get that? After I'm done, I wrap up the lesson, I could come over and help you with that. If your calculator is not behaving. Guys at home, you can punch buttons, see if that works for you. Remember, you have to be in radians, right? All right. I got like 2 more examples of these word problems. Temperature is sinusoidal. It repeats in a cycle. Tides are sinusoidal. They repeat in a cycle. At a seaport, the depth of the water, h meters at time t hours during a certain day, is given by this wonderful-looking formula. State the period, the amplitude, and the phase shift. All right. What do you notice about that formula? I hope you notice that it doesn't really look like this. It needs factoring. So we're going to factor this thing so that it looks like that, so that we have a clear b value. Okay, we do have a clear a value. It's 1.8. This time I'll remember the actual trig function. There we go, sine. And now inside this bracket, I need the variable minus a constant. I don't want this there, so I'm just going to rewrite this as 2 pi over 12.4 times t minus 4. And those zeros don't really mean anything, but I'll write them anyway. And we have a clear d number. Does everybody get that basically that's just a factoring of this? And I can actually simplify it even more, because 2 goes into 12.4 very nicely. There. Now it's just a matter of reading stuff. Let's do amplitude first. It's the easiest. 1.8 meters, right? There's units on this one. Phase shift. Now, the h variable is in meters, but the t variable is in hours. And phase shift is the change in the hours. So this is positive 4 hours, right? Everybody see where I'm getting these numbers from? I'll use a highlighter. The 1.8 is here, and the 4 is here. That just leaves the tough one, the period. What's period again? Period is 2 pi divided by b. Well, what's my b value? My b value, let's use a different color. Let's use, I've already used blue. Let's use this lovely green. My b value is right there. So that's going to be 2 pi divided by 6.2. And no, I wouldn't give you a calculator for a question like this. You should be able to handle that. Dividing when you're in fraction land is just timesing by a reciprocal. The pi's cancel, and you should be able to double 6.2. And period, is that a meters number or an hours number? Think about it. It's a time, right? So that's hours again. Yes, they make me take off half marks if you forget on questions like these to put units on answers when there should be. All right, let's do some algebra with this lovely equation now. What is the maximum depth of the water and when does it occur? Okay, maximum depth would be my A value, or sorry, my D value, plus my A value, which is 3.1 plus 1.8, which is 4.9 meters. That would be my maximum. When does it occur? Okay, well, this height goes basically here in the equation. So I will put that at the end. I think I'll use the factored version of the equation. So 4.9 equals 1.8 times the sine of pi over 6.2 times t minus 4 plus 3.1. All right. So what do we do here? This is exactly the same as the last example we did. We let, and they don't give me much room here, we let theta equal this complicated part. And then we solve 4.9 equals 1.8 times the sine of theta plus 3.1. All right, algebra says we minus the 3.1 from both sides. And look at that. I actually probably don't need a calculator for this part. That's going to be, I'll just move over to here, sine theta equals 1. And when is sine theta equal to 1? When theta is pi by 2. So this mess here is theta, and theta is pi by 2. So pi by 2 has to equal this. I can divide both sides of the equation by pi. I can times both sides of the equation by 3.2. And t is equal to 7.1 hours. Isn't that nice? All right. What is the depth of the water at 5 a.m.? So in other words, I would like to know height at 5. So 1.8 times the sine. Again, I'll use kind of the factored form of this equation here. So it was sine of pi over 6.2. Oh, I've got it right there in front of me. Height of, go away. Height of pi over 6.2. And now the time is 5 a.m. We're assuming time of 0 is 0 at midnight, right? 0 a.m. So that's 5 minus 4 plus 3.1. This you'd need a calculator for. So let's punch buttons, shall we? I might kind of do that 5 minus 4 is 1 to make my life easier. Why punch buttons I don't need to? 1 times anything's itself. There. All right. If it didn't work for you last time, try this time again. Punch buttons. Don't forget to get in radian mode. 0.8 times, open a bracket, pi divided by 6.2, close my bracket, sine plus 3.1. And there we go. At 5 a.m., 3.974 meters. I'll just round to 3 decimal places. Remember, if the question doesn't tell you, we don't care. If the question does tell you, you got to do what it says when it comes to rounding. Look at this. How simple was this math? Some sea captain somewhere in the Suez Canal was unable to do this math, could not calculate how deep the Suez Canal was at low tide, and got a ship stuck that has cost the world. They're saying now that the actual damage to the world's economy might be in the trillions of dollars. You guys aware of that? That there was a ship stuck in the Suez Canal for several weeks? This was the math they couldn't do. Or somebody goofed up. They haven't yet laid blame. All right, one more, and we'll call it a day. More water. A tsunami is a very fast-moving ocean wave caused by earthquakes that occur underwater. The water will first move down from its normal level, then move an equal distance above the normal level, then finally back to the normal level. I like that. First it moves down. Maybe you've heard that, right? That if you're ever on a beach on the ocean, all of a sudden the tide like disappears on you, like the water recedes from you very quickly. Time to start running. A tsunami is on its way. It goes back into the ocean first. So anyway, there you go. See, we're teaching you math and beach safety at the same time. Okay, so finally then back to the normal level. The period of the tsunami is 16 minutes with an amplitude of 8 meters. The normal depth of water at Crescent Beach is 6 meters. This time we got to make the equation, so let's see. We know that the maximum is, well, let's see. The amplitude is 8 meters, and the normal depth is 6. So the maximum is 8 plus 6, which is 14. The minimum would be the 6 minus the 8, which is negative 2 meters. And I guess I should put meters on these. I lose my half mark for units there. Right? And again, how could the water level be minus 2 meters? In other words, it would drop first before the tsunami hit. All right. So there's max and min. And then for B, let's make an equation. What do we know? Amplitude is 8 meters, so that's my A. Normal depth is 6. That's my D. The period is 16 minutes. So P is 16, which means that B is 2 pi divided by B, which is 2 pi over 16, which is pi over 8. And okay, let's say that we'll choose our starting point chosen when water is at normal level. And then, if we start at normal level, what trig function do you think we should use? We should use sine, right? Because sine starts not at a maximum or at a minimum, but right in the middle at a node. So that means we'll use sine. But careful, it goes. Some people are already pointing downward. It goes down first. What does that tell me? A has to be negative. So go back up and put a negative on the 8. And I think we're ready for an equation. Let's write it in function notation. Height as a function of time is negative 8 for A, sine. One of the perks of using the starting point at 0 is that my C value is 0. So I guess I could write that down. That means C is 0. So I can just open a bracket and say that it's B times my variable t, and I don't have to worry about plus or minusing anything because I'm not shifting left to right, plus 6. And then very often there'll be another question after that. There'll be like a C part to the question. Here, let's make up a C part. C, how many minutes before the height of the tsunami is, let me pick a good one here. Um, 30, no, wait a minute, it doesn't go that high. What is the absolute maximum we said? 14. Okay, let's just 14 meters. It's max. There we go. So what do? What's the algebra here? Height is this part of the equation right here, right? This is my height. So that's where I'm going to plug in my 14. And now I does algebra. So I'm going to let theta be this complicated part. So I'm now solving an easier looking equation. I'm going to minus 6 from both sides. I'm going to divide both sides by negative 8. And then I'm going to ask myself, say self, when is the sine of theta negative 1? Sine of theta is negative 1 down here at 3 pi by 2, right? So theta equals 3 pi by 2. So going back to the equation involving t, theta is pi over 8 by t, and theta is 3 pi by 2, so 3 pi by 2 has to equal pi over 8 times t. Now it's just a matter of solving for t. I divide both sides of the equation by pi over 8, and dividing by a fraction is timesing by the reciprocal of that fraction. The pi's cancel. 2 goes into 8 4 times, and t is equal to 12 minutes. You have 12 minutes before the maximum of the wave engulfs you on this lovely beach. And there you go. All right, I'll stop the lesson there for the video. Whoever's watching it, thanks for watching.